Hi everyone. In this section, we will be solving some inequalities. This is section 1.7 of our textbook, so chapter 1, section 7, solving inequalities. Chapter 1, is supposed to be review, so this is going to be brief introduction or reminder of how we solve inequalities. Alright, so when I solve an inequality, and I have one here, 3x is less than 9x plus 4. The thing to do is we can treat it as an equality, but we have to be a little careful. So the first thing I'm going to do is subtract my 9x from both sides. That will give me a negative 6x is less than 4. My next step is to divide both sides by a negative 6. So this would give me a negative 2/3. But when we divide or multiply or divide by a negative, it switches the inequality. So it goes from a less than symbol to a greater than symbol. So x is greater than negative 2/3. And we can write this solution in a number of ways. One, simply as this inequality statement. We could write it in set notation. So the set of all x's such that x is greater than negative 2/3. So that's kind of set builder notation. We could write this on a number line. So here's a number line with 0, 1, 2, negative 1, negative 2. Negative 2/3 is somewhere here. With a strict inequality, we like to use an open dot. So this would be our negative 2/3 sitting in there. And we want to go greater than, so we would be going this direction. Okay, so that would be like on a number line. Some people have used open dots versus closed dots. Others have used round brackets versus square brackets. In this case, it would be a round bracket. So this would be like on a number line. We also like to use interval notation, which kind of looks like a point. So we are going to use a round bracket because it's a strict inequality. So a negative 2/3 all the way up to infinity. And we always use a round bracket with infinity because we never get there. We don't include infinity on our scale. So this would be an interval notation, number line, set builder. I should probably write that down for you. Set builder, number line, interval. So notations. All right, here's another one. We have kind of a compound inequality. One thing you have to kind of remember is this compound inequality has to make sense. So when you read the entire thing, so 4 is less than or equal to this mess, which is less than 13, the outside edges should make sense. So 4 is less than 13, so we're okay. What we're going to do is we want that x, to isolate that x in the middle. So the first thing I'm going to do is I'm going to add 2 to all of the pieces. So that's going to change the 4 to a 6 and that 13 to a 15. So I'm adding 2 to all 3 pieces. And then I'm going to divide by 3. And when I divide by 3, since it is positive, it does not change those inequalities. You'll also notice that the final statement makes sense, that x is somewhere between 2, including 2, not including the 5. So if I were to use these 3 different techniques for writing it, I could write this as a set of all x's such that 2 is less than or equal to x is less than 5. On a number line, put 0 down here. 1, 2, 3, 4, and 5. I would have a closed dot on 2 an open dot on 5, and we would go in between the 2. That sometimes gets a little hard to read, hence the reason the number line idea is disappearing, and we're leading more towards the interval notation. In an interval notation, since we have the equality included on the 2, we use a square bracket. So we're going to go from 2 up to 5, not including the 5. So this is an interval from 2, including 2, to 5. One thing to note when you're writing your intervals, we do go from smallest to largest, kind of like the number line. We read left to right, so smallest value to largest value. Okay, let's do a couple more. I'm just going to do one of these quadratics because they're both done the same. And what I'm going to do, and we will see this again, so that's why I'm just going to only do one, because we'll see this again when we hit chapter 2 or 3. I think it's in chapter, well, maybe it's in chapter 4. But it's coming up in one of the later chapters. We will really dive into this completely. So I just want to refresh our memory how we did something like this with a quadratic inequality. And what we do is we need to move the 6 over. So kind of like you would a regular quadratic. And we'll have that it's less than or equal to 0. Okay. And now what we're going to do is try to factor this just as if this was a equal symbol. And this one does factor, so two numbers that multiply together to give me a positive 6, that add together to give me a negative 5, is x minus 2 and x minus 3. Setting each of these equal to 0, x minus 2 equals 0, x minus 3 equal to 0, adding 2, adding 3, x is equal to 2 and x is equal to 3. Then what we do is we're going to break this up and put those numbers on a number line. So number 2, and I'm going to put a 3 here. Kind of breaks the number line into 3 regions. So everything that's smaller than 2, values between 2 and 3, and then again 3 above. And what we want to do is we want to know where this thing is less than or equal to 0. Okay, I know where it's equal to 0. It is equal to 0 at 2 and at 3. So we will be including those values in our solution. But I don't know where it's smaller than 0. To figure that out, what we will do is just take a test point from each of those regions. So I'm going to take a test point of a value that is smaller than 2. The nice number that's smaller than 2 is 0. And I'm going to just look at what it happens when I substitute that 0 into this side of the equation. Now, I don't care exactly what the value is. I just need to know, is it a positive number or is it a negative number? Because I just want to know it's smaller than 0. So I'm looking for my negative values. So substituting 0 in here, I would have a negative number on that first piece because 0 minus 2 is negative. And I'd have a negative number on the second piece because 0 minus 3 is also a negative number. And a negative number times a negative number turns into a positive number. Testing a value between 2 and 3, say 2.5. Putting it into my factored form. 2.5 minus 2 is a positive. 2.5 minus 3 is a negative. Turns out to be a negative. Positive times a negative is a negative. Substituting something bigger than 3, say 5. 5 minus 2 is a positive number. 5 minus 3 is a positive number. Positive times positive is positive. So we were looking for where it is less than or equal to 0, so we wanted this region right here. So that means our answers are where x is between 2 and 3, but including those because we want to include where it was equal to 0. So in set builder notation, we would write it as x such that if I were doing it on a number line, I'd have my 2 points solid line and then go between them. Set builder notation, 2 up to 3 square brackets on both. So again, we will do these problems in more detail in another chapter. Just kind of wanted to remind you of this idea of getting test points on intervals. The last one I have also is one that we will see again in that same chapter. The thing I want to remind us is a lot of times students would just want to multiply by 1 minus x to both sides and make the problem easy. That will not work because I don't know if 1 minus x is a positive result or a negative result. So what I need to do is move the 1 to the same side because I want to get a 0. So I have 1 plus x over 1 minus x minus 1 greater than or equal to 0. Now I'm going to get a common denominator, which is basically that 1 minus x. So 1 plus x minus that 1 minus x all over the 1 minus x greater than or equal to 0. So my common denominator, I rewrote this 1 as 1 minus x over 1 minus x and then subtracted. I'm going to distribute that negative 1 through. So negative 1 plus x. And then I'm going to combine my like terms on the numerator. So I have 2x on the top all over 1 minus x greater than or equal to 0. Okay. Now what I need to do in this problem is we will find the zeros of both the numerator and the denominator. So we're going to look at where 2x is equal to 0 and 1 minus x is equal to 0. This first one I'll divide both sides by 2, which gives me x is equal to 0. On this one, I'm going to add x to both sides, so x is equal to 1. These numbers I will put on a number line. So 0, and I'm going to give myself some space, the number 1. Again, it breaks it up into 3 regions, so I'm going to do a test point. And again, I'm just looking for where it's positive or negative or equal to 0. Now it's equal to 0 when the numerator is 0, so this place here. This one is where the 0 was in the bottom, which caused a problem. I can't have zeros in the bottom, so I'm going to have to throw that point out. So I'm going to put those solid dots and that open dot in my little number line right away to remind me if I can include them or not include them. Okay, since I had the equal sign here, I'm going to include this. If this was a strict inequality, so without the equal, I would not include either of them. Now taking a test point, so I'm just going to take, say, negative 1. And again, I just want to know, is my value positive or negative? So my numerator is going to be negative. And I have 1 minus a negative. So that'd be a positive. So a negative over a positive is a negative. Putting in a value between 0 and 1, say maybe 0.5, I would have a positive over 1 minus 0.5, so that would also be positive, so I'd get a positive. Here let's put in the number 2. I'd get a positive over a negative, which is a negative. Okay, and now we want the ones where that is greater than 0, so meaning positive, so again, here we want this middle region. If I had it going the other way, I would have wanted the negatives, which means I would have had 2 regions. Here it is in the number line between the 2. If I wanted in interval notation from 0 up to 1, round bracket on the 1. If we had the interval going the other way, the answer would have been negative infinity to 0, including the 0, and then start from 1 again to infinity. And we put a little union symbol, a little U in between the two to tell us that we are adding both of those together. So this is kind of like our set addition symbol. So there we go. So there's a little bit on how we solve some inequalities. Again, these last 2 that we did will show up again in further section, a different chapter. So look for those again when we get there.